Welcome to Circles, Lesson 3, Calculating Area. Just some reminders from our previous lessons. The diameter is the line segment all the way across the circle. It's twice the size of the radius. Multiply the radius by 2 to get the diameter. The radius is from the center to the edge of the circle. It is half the size of the diameter. You would divide the diameter by 2 to get the radius. And pi is just a number that's normally calculated using 3.14 or 22/7. All right, area. Area is the amount of space inside a closed shape. It is the number of square units that will fit inside the space. Example, take this oval here. If I drew these square units, I have these and I have these area spaces left over. Well, if I take my square and cut them in half, I can cover up most of that spot and most of that spot. And so this shape would be about 10 units squared, or square units. If you counted them, there's about 10 of them there. Now, if those squares were really, really small, then it would take a lot more time. So we use formulas. Right now we're dealing with circles, so we're going to calculate the area of circles with a formula. The area formula is A equals pi r squared. And, oops, I went too far. R squared. Now, r squared isn't, that 2 is an exponent. It just means pi times r, and that's what you do. You take pi, which is, we use 3.14, times your radius. All right, so let's look at a couple of examples. The steps are determine the radius of the circle, and then substitute the radius into the formula and solve. All right, we have our circle here. Because this line segment goes from the center to the edge, we have a radius. So our radius is 8. So we take our circle formula for area, pi r squared, and we're replacing the r because we know that it is 8. So the r comes out and we put in 8. So we have pi times 8 squared. So that's just pi times 8 times 8. 8 times 8 is 64, and 64 times pi, which we use 3.14, so it's 200.96 millimeters squared. Let's look at another one. This time, our circle gives us a diameter. The diameter is 10 meters, so the radius is going to be 5 meters. So instead of r squared in our formula, we would replace the r with 5. And then 5 squared is 5 times 5, which is 25, times pi, and pi is 3.14, so we end up with 78.5 meters squared. All right, calculate the area of a circle whose radius is 2. All right, so if my radius is 2, I have a circle, and it's the little line that's 2. And so area formula is pi r squared. Let's see if I can change that color. Maybe it'll be a little easier to see. All right, my radius is 2. So I have A equals pi times 2 squared. Well, 2 squared is 4. And so that would be 3.14 times 4. So we end up with 12.56. And a way to check your answer is you can look at 3 in your pi and 4 as your radius squared, and look at the first number of your answer, and if 3 times 4 is 12, then you've multiplied correctly. Think about the reasonableness in the answer. Now let's see if I can get out of the... Okay, so now we're going to try one with a diameter of 6. So again, we have our circle, and the diameter goes all the way across. So that's our 6. So because our formula uses radius, and the radius is half, just from here to here, half that diameter, our radius is going to be 3. So set up your formula, pi r squared. So then we get pi times 3 squared. Well, 3 squared, 3 times 3. So we get pi times 9. So that's going to be 3.14 times 9. So we get 28.26. And again, check for reasonableness. Sorry about that. Check for reasonableness on your answer. 3 times 9 is close to 27. All right, our diameter is 20. So if our diameter is 20, our radius is 10. And that would just be units because they're not labeled there. So pi r squared pi times 10 squared so we get pi times 100. And if you remember, if you're multiplying by 100, you just move your decimal over. It didn't give me the highlighter. So we would have 3.14. Where'd my pen go? Times 100. And all that means is move your decimal over, so we get 314 units. And then it's 3 times 100, close to 300. All right, in my next video, I will have examples of both circumference and area problems. I'll show you how to work backwards to find the radius or diameter given either the area or the circumference, and how to find the area given the circumference and the circumference given the area. And as always, thanks for watching. Please like and subscribe. You can always email me at bethemath@gmail.com.